The Boogers Sphere was expected to be ordinary: metal, mass, reflective surface, nothing unusual. Yet when NASA completed the final analysis, the surface data refused to make sense. The object wasn't unstable, it was inexplicable. The only definite conclusion the report reached was that the Boogers Sphere existed, and conventional physics could not fully account for it. The impact occurred at coordinates 3 degrees 54 minutes north. In Western Colombia's geological records, a single curious entry stood out: a brief seismic pulse near the town of Buga at 2:01 a.m. Field investigators found a shallow depression encircled by scorched vegetation. It showed none of the usual signs of an earthquake: no aftershocks, no secondary waves, just a fleeting compression in the topsoil, confined to an area smaller than 10 meters. At the center rested a metallic sphere, calm and unremarkable, measuring just under 20 centimeters in diameter. From every angle it looked uniform, without seams, welds, or heat marks from impact. Its surface had a dull, graphite-like sheen, and remained slightly cooler than the surrounding soil. Portable spectrometers detected a faint low-frequency signal near 12 Hz, inaudible to humans, yet strong enough to interfere with nearby sensors. The signal disappeared when the sphere was grounded electrically, and reappeared once it was isolated. Initial measurements contradicted one another. Density readings fluctuated between trials, and magnetometers recorded weak polarity shifts with no apparent external cause. Radiation levels were normal, yet the surrounding soil retained a distinct electrostatic ring. Each individual reading seemed plausible, but when compared collectively, they defied consistency. For cataloging, it was labeled Specimen B 25-inch Bugger and moved to a secure facility in Cali. Under laboratory lighting, the sphere's apparent simplicity began to unravel. High magnification imaging revealed no grain boundaries or machining marks. The material behaved as one continuous lattice. Narrow band light hitting the surface did not reflect straight. It bent slightly along the curvature before dispersing, as if the reflection depended on the observer's angle rather than the source. Each test confirmed the same result. The sphere was stable, but the data describing it was not. Metallurgy without a maker. Attempts to extract a surface sample failed. Diamond-tipped tools slid across the surface without leaving marks. The sphere had no outer layer to chip or peel. It acted as a single, uninterrupted structure, metal drawn into perfection with no origin. Spectrographic analysis revealed titanium and nickel where expected, but also unusual peaks in regions absent from the periodic table. Instruments were working correctly. It was the material itself that refused classification. Electron microscopy revealed a flawless lattice with no crystals or fractures. Light diffused softly across the surface, absorbed and re-emitted almost as one. Technicians described it as alien, unfamiliar, though not hostile. Compression tests added to the mystery. The sphere resisted extreme force, but instantly returned to its original shape. Energy readings spiked each time it flexed, as if storing and releasing stress rhythmically. By the week's end, one story emerged. The sphere had been crafted intentionally using methods unknown to humanity. It was neither manufactured on Earth nor naturally formed. It was metal without a maker. Attention shifted inward. High-resolution tomography revealed 16 concentrated points inside, symmetrically arranged around a dark core. The spacing was precise, all nodes aligned in the same plane. There were no welds or cavities. 3D reconstructions showed thin filaments connecting the core to the shell, forming a silent internal framework. The lines followed mathematical ratios reminiscent of harmonic intervals in orbital mechanics. Ultrasound testing confirmed dynamic responses. Low-frequency waves scattered through the inner nodes, and at certain frequencies, all 16 points vibrated briefly in unison. The motion was intrinsic, not caused by temperature or contact. The structure had no mechanical purpose, stored no energy, amplified nothing, yet it responded as though sensing its environment. Lab notes repeatedly observed the same phenomena. The sphere behaved like an active system, aware of being observed, almost alive. In isolation resonance tests, transducers emitted frequencies from infrasonic pulses to the upper limits of human hearing. Initially, nothing occurred. Then, at 11.9 Hz, faint magnetometer fluctuations appeared. At 432 Hz, the effect intensified, accompanied by a 0.5 degrees rise in surface temperature. Thermal imaging revealed concentric waves of energy moving across the sphere, each beginning near an internal node and circulating the surface before fading. External temperature changes triggered the same pattern. The sphere compensated, restoring its cycle within minutes. Data suggested an internal feedback. System regulating thermal energy. No electrical or chemical reactions occurred. The object remained inert to sensors, yet acted like a living system maintaining equilibrium. For the research team, it was a turning point. The anomaly was no longer passive. It was performing. The mass anomaly. Mass is supposed to stay constant. It's one of the easiest physical traits to measure, and one of the hardest to argue with. Yet over the next few weeks, that basic rule refused to apply. Every morning, the sphere was weighed exactly the same way. Same scale, same calibration, same temperature. For the first 3 days, the reading held steady at just under 2 kilograms. On day 4, it jumped by 180 grams. The day after, it climbed again. Within 10 days, its measured mass had doubled. Recalibrating didn't change a thing. The equipment was flawless, but the readings weren't. The first assumption was environmental interference. Moisture, stray charge, vibration. Any of them can skew sensitive measurements. But the same pattern continued even when the sphere was weighed in a vacuum chamber, in inert gas, and inside electromagnetic shielding. The increases weren't chaotic. They followed a curve, rising quickly, leveling off, then holding still for hours. When the object was lifted from its cradle and set back down, the mass dipped slightly, as if its state shifted when moved. Meanwhile, magnetometers detected a faint synchronized fluctuation in magnetic flux. The shift was too small to explain the mass change, but it mirrored the same rhythm. Thermal sensors picked up another link. The sphere warmed slightly whenever its weight rose. The correlation hinted at an internal mechanism, something converting absorbed energy into a gravitational signature. The idea of self-adjusting mass broke every rule of known physics. No chemical reaction fit the behavior, and the alloy had no moving sections, no cavities, nothing that could expand or shift. It appeared solid, yet acted like a system redistributing energy in ways mass spectrometry couldn't register. When the strange readings finally stabilized, the sphere settled just above 10 kilograms and refused to change further, as if it had reached a state it preferred. Primes, ratios, and hidden code. Earlier tomography scans displayed patterns too orderly to dismiss. Once the sphere's behavior became stable, the focus moved from how much to what does it mean. When plotted in 3D, the 16 internal nodes weren't merely spaced apart. They followed ratios that repeated with mathematical consistency rarely seen in nature. The angular spacing matched prime intervals. The distance from each node to the core followed harmonic ratios found in orbital resonances, not random construction. Initially, researchers wrote it off as coincidence, but modeling software translated the geometry into numbers, and the pattern held. Each node cluster generated values matching prime numbers up to 53, separated by gaps aligned to Fibonacci spacing. In physics, symmetry that precise rarely appears by chance. It suggests optimization. Whatever this thing was, its design balanced dimensions far beyond what a simple sphere would ever need. Digging deeper, the geometric data was converted into a digital matrix. Analysts ran signal processing algorithms to search for recurring structures. The output looked like binary data, but not the type that translates into text or images. Instead, it formed a continuous web of ratios, as if the geometry stored information physically rather than digitally. The team avoided calling it code, but the similarity was undeniable. Simulations of stress and resonance added another clue. Whenever a model hit one of those prime-based frequencies, the internal structure settled into equilibrium faster. Like a mechanism built to absorb energy only through specific harmonics, it reacted to mathematics the way tuned instruments respond to sound. Isotopes from nowhere. Once the internal mapping was complete, researchers returned to the question of composition. High-resolution mass spectrometry was the obvious choice. The results were anything but obvious. Titanium, nickel, and trace carbon appeared, typical for advanced alloys, but the isotope ratios were wrong. The titanium showed an unusually high level of T50, far above anything refined on Earth. Nickel displayed the same imbalance. Heavier isotopes were twice as abundant as they should have been. This wasn't equipment failure. Standards confirmed every measurement. The atomic signature was real, just unfamiliar. To rule out contamination, a sample of surface residue was isolated and vaporized. The anomaly repeated. Every element had isotope distributions inconsistent with any Earth-based source. The conclusion was simple and uncomfortable. The alloy wasn't formed under Earth-like conditions. Even if built here, its raw material came from elsewhere. Spectroscopy of the non-metallic layers revealed another surprise. Ultra-thin carbon strands ran between metallic sheets, forming microfiber-like structures throughout the lattice. Each strand was only a few atoms thick, but extended across significant distances, stitching sections of metal together. Under magnification, it looked woven, not cast. No known manufacturing process can create that pattern without collapsing under heat. Simulated additive manufacturing failed instantly. Theoretical models suggested that forming such fibers would require gravity, pressure, and temperatures far beyond anything achievable on Earth, closer to conditions inside dying stars. Yet the sphere's surface stayed cool, and the alloy appeared untouched, as if it had never experienced extreme forces at all. Models of origin. By the time the composition data was settled, the investigation shifted from classification to explanation. Everything about the sphere contradicted one branch of science while matching another. Its geometry echoed orbital physics. Its alloy reflected stellar isotope patterns. Its reactions to heat and resonance resembled systems that regulate themselves, not random lumps of metal. 3 possible origins emerged. The first suggested a functional purpose. An engineered probe meant to gather and balance energy. Its harmonic response, symmetrical structure, and self-stabilizing temperature all pointed to an adaptive mechanism, a passive device that kept itself stable by resonance. Under this model, nothing was symbolic. Everything was operational. The second model saw information, not function. The geometric patterns and isotope distributions could act as a form of material-based encoding, storing data physically through ratios rather than binary digits. Each internal node might represent a unit of information. The entire sphere could be a physical archive designed to outlast time, its message buried in arrangement instead of writing. The third explanation was the most straightforward and the hardest to eliminate: a natural object, formed through processes Earth has never observed. There are cosmic environments, supernova debris fields, high-pressure nebular regions, where metals can weave into uniform lattices under extreme forces. A fragment from such an environment could condense into a shape dictated by equilibrium, not intention. But the precision remained the problem. Nature rarely produces near perfection without some guiding mechanism. Official reports left all 3 theories unresolved. None fit entirely. Each required too much speculation to be definitive. What they all agreed on was simple. Whatever the sphere was, it behaved according to physical laws we haven't discovered yet. Containment lock. Today, the sphere is stored inside a vacuum-sealed containment chamber at a research facility in Mexico. The chamber maintains constant temperature, pressure, and electromagnetic neutrality. Sensors line the walls, tracking every shift in heat, magnetic field, and mass. None of these readings have changed much in months, but the monitoring continues, half routine, half reassurance. Every non-destructive test has been performed. Tomography, spectroscopy, resonance mapping, neutron imaging, all confirm the same contradiction. The material is stable, the structure is flawless, yet the measurements won't stay consistent. The sphere is predictable until someone claims certainty. Then its properties drift just enough to evade explanation. Occasionally, small irregularities still appear. The thermal cycle speeds up or slows down by a few seconds. The low-frequency oscillation returns briefly, matching earlier logs perfectly. Whether these shifts come from the sphere itself or from external influences remains unknown. The object offers no message, no signal, only existence. Its mystery lies in persistence, not action. For now, research has slowed to archiving data, reviewing simulations, and developing theories. Future instruments may reveal details at higher resolutions. Until then, the sphere waits, still as ever, active yet inert. It doesn't corrode, it doesn't degrade. It remains a contradiction, matter behaving like intention, precision without explanation. Whoever made it left no message except the object itself, and perhaps that was the only message they meant to leave. That's all for today. Share your thoughts about the sphere down in the comments.